Welcome back, folks. We're going to do homework for section 12.5, which is all about the normal distribution. So determine if the statement is true or false. The range of a true normal distribution is about 6.7. Now, y'all, the range of a normal distribution can be infinity. Okay? It could go from negative infinity to positive infinity. What is standard about the normal distribution is the mean, median, and mode are the same for a normal distribution, and it's right in the middle of the data, and you get a bell-shaped curve. But the range can be infinite, which in this particular case is right there. But I do want to read all the other ones. The statement is false because the range varies with the height of the curve. The height of the curve doesn't have anything to do with the range. Okay. The statement is false because the range is infinite. So true. The statement is true because there are 3.35 standard deviations on either side of the mean. False. The statement is true because 100% of the values fall within 6 point standard deviations of the mean. That is also false. So we're talking about the range is infinite. Next question, determine if the statement is true or false. The mean, median, and mode are all equal in a normal distribution. You know that's true, right? The statement is true. Uh-oh, pen's not working. Hold that thought. There we go. The statement is true. The mean, median, and mode are all equal in a normal distribution. All the others say the statement is false. And I'm just glancing through those options. Nope. They're the same. There's just no way around it. By definition, they're the same. Next question. In a normal distribution, about 95% of all data values lie within 2 standard deviations of the mean. Now, that sounds about right, but maybe you want to go verify. So let's go scroll right back in our notes. I have to scroll back kind of far. One page is this page. Remember this, the 95 that's shown right here. That represents the 2 standard deviations of the mean, but if it helps you feel better to look at the previous page, that was not the previous page. How about this guy? Right here it says it very clearly that 95% lie within 2 standard deviations of the mean. So we know for fact. So we know for a fact that 95%, 5% is 2 standard deviations of the mean. Let's read it again. In normal distribution, about 95% of all data values lie within 2 standard deviations of the mean. This statement is true. And all the others are false. And we're going with that. That is it. Next question. Identify the variable quantity as discrete or continuous. Now remember, discrete means the outcomes can only take on specific values. It doesn't vary within a range of values. That would be continuous. So let's look at our problem. The number of odd numbers in 30 rolled dice. Okay, so if we roll 30 dice and we count the number of odd numbers, could that be 2.7? Well, no, because you have 30 rolled dice. It's either going to be 1 or 2 or 3 or 4 or 5 on up to 30. There's no other values in between that you can get, so we're going to say that this is discrete. Absolutely has to be. Okay, next question. Identify the following variable quantity as discrete or continuous. We have another one of those. The time shown on a digital, hey, this is important, on a digital watch. Okay, so on a digital watch, we're talking, it might be 11:35. Okay, you don't get within a range. You might think you even have seconds, 11:35:23, but you still don't get that part of a second. So these are discrete values on a digital watch. Now, if you're looking at a clock, yeah, right? It's continuous all the way around. It doesn't necessarily just click from one to another, although I've seen second hands that click. But for a digital watch, this is discrete. Something to think about, but it is definitely discrete. Now, I just saw another example that I did not include that talks about the average weight of babies born in a certain time, right? So if the average weight of babies born in a year at a certain hospital, then that's not going to be discrete, right? Because they don't weigh just 2 pounds or 3 pounds or you see what I'm saying, or 2.5 pounds. Although you could get into the measurement tool, but that average could keep going out. You know, it could be 4.3333. Well, it's not. No, it could be 7.333333 pounds, right? So that is not a discrete value. That is a continuous value. Although I did not present that question here, you may run into that one when you do your homework. Okay, here's where it gets real. Okay, these are the table problems. So it says, suppose 170 geology students measure the mass of an ore sample. Due to human error and limitations in the reliability of the balance, not all the readings are equal. The results are found to closely approximate a normal curve. So all that to say is we're dealing with a normal curve with the mean 85 grams and standard deviation 1 gram. Use the symmetry of the normal curve and the empirical rule as needed to estimate the number of students reporting readings of more than 85 grams. Okay, now let's think about this. I found that I did not have to use the table to do this problem. Don't worry, even if we don't use the table on this problem, we're going to use the table on other problems. But let's just think about this. So there's our normal curve, right? Now it says that the mean is 85 grams. So right here, your X bar is 85 grams. So remember that is your mean, or X bar is the way I read that, okay? And the standard deviation is 1 gram, so you could get the percentages by counting out the standard deviation. But it says use the symmetry of the normal curve and the empirical rule as needed to estimate the number of students reporting readings more than 85 grams. Okay, so we're talking about more than 85 grams. I'm shading that for you. Anything to the left will be less than 85 grams. Anything to the right is more than 85 grams. Now, you might not have caught this, but remember, this is important, that if you're talking about half of the graph, that is 50% of the area. Okay, that is your area under the curve is 0.50, which is 50% of the data lie to the right of the mean, 50% of the data lie to the left of the mean. Okay? Okay, then they want to know the number, make sure you read these, the number of students reporting readings more than 85 grams. Okay, so that's 50%. So I multiply 50%, that's a percent sign, y'all, times 170. And what is 50% times 170? Well, change that 50% to a decimal, 0.50 times 170, which is the same as half of 170. What do you get? I got 85. And notice we did not use the table for that. I did not have to click on either of these. They give the table in two parts, part 1 or part 2, and it just depends on where your data is on the table, which one you need. So I always open the first one and scroll through, then open the second one if I need it. But this one I didn't need it because it said more than 85 grams, and we already know the X bar is 85 grams, y'all. So that handled the question right there. Now, I was going to move on, but I guess you really need to see how you would do this without, I mean, what if it said more than 86 grams, right? So let's talk about how you would actually do this problem, not just by logically getting our way through it, okay? So what you have to do is find the value of the z-score, okay? That's familiar? So you have z, remember, equals to x. Okay, so your X is 85 grams minus the average, or the mean, is 85 grams. That's our X bar over the standard deviation of S. And that's why they gave us that 1 gram, but we didn't need it because they gave us the average, and we knew that 50% was above that. But anyway, this is how you would do it. And then 85 minus 85 is 0 over 1, which is 0. So our z-score is 0. Okay, and when you look up 0, stand by, there it is. Now, notice I've got some stuff highlighted over here. I'm going to get rid of that because we used that earlier. So I look up 0, and look, my area is 0. Well, no kidding, right? Because if you go from the average and you scoot over to that score, and that score is right on top of that, then it gives you 0. Okay, so I'm back over here. Actually, I'm doing this version of it. So I draw the picture again, we have 85 grams is our X bar, and we're looking at 85 grams. Well, the area under the curve between 85 and 85 is 0. But remember, we're calculating the tail. Whenever you calculate the tail, remember you do 0.5 minus the A value on the chart, which was 0, and that gives us 0.5, which is that 50% that we multiplied by the 170. I almost wrote 85, but that was my answer, times that 170. Okay, so that's how you would do it if we didn't use logic to do it. So I did it both ways. Don't worry if the second version didn't make sense. We've got more problems where we're going to have to take real values, convert them to z-scores, and look them up on the table. Okay, so don't stress. Okay, let's see what we can do with this problem. Okay, so on a certain intelligence test, the mean is 110 with a standard deviation of 10. Okay, so we have an X bar, that's my 110. Let's write that down as we read. So my X bar, let me get my pen working. There we go. X bar, okay, is 110. And my standard deviation, my S is 10. So we've got to start. It says the results come very close to fitting a normal curve. That's good because we couldn't do the problems the way we're doing them if we didn't know that it was a normal curve. So we know that it fits this condition right here. Okay. Suppose the test is given to a very large group of people. Use the empirical rule to find the percentage of people whose test scores are more than 110. All right, let's shade on the picture, right? So remember, my X bar is 110. If I put that on my curve, that's right there in the middle. It's asking for the percentage that scored more than 110. Now, if you've been paying attention, I bet you know this answer. We don't need a table to look this up. Remember, when you've got half of that curve shaded, that is 0.50. That's 50% of your area. Okay, so the answer to this question is 50. Notice they've already put the percent out there for us, so 50 is all we have to type in. Very similar to the question that we just did. All right, next question. So find the percent of area under a normal curve between the mean and the given number of standard deviations from the mean. It says note that positive indicates above the mean while negative indicates below the mean. So I believe in pictures, y'all. So if I draw a picture of this, I want you to think about what we're doing. So here's our normal curve, roughly, symmetric. Okay, now this is negative 1.2. Now that it says negative 1.2 is the number of standard deviations from the mean. That is also your z-value. Okay, so that is your z-value. When they say the number of standard deviations from the mean, that is z. Okay, all right. Now, find the percent of area. So what we're trying to find between the mean and that given value. So this is what we're trying to find right here, that area. Now, if I have a z-score, that's exactly what I look up. Now, remember, you can't look up a negative z-value. You look up a positive, and it wouldn't matter if it was 1.2, which lives over here. It's going to give you the same area on this side as it would give you on this side. So let's click either page 1 or page 2. I'm going to go ahead and tell you I've clicked page 1. And we're going to try to find 1.20. Okay, now remember I've got some stuff highlighted. I'm going to get rid of that because we're not using that. And we're going to highlight a different value when we find it. So you scan through there. Do you see 1.2? Now notice I'm only showing you part of the table, but I have the part that we need. And here it is. So 1.2 in the Z column gives me 0.385. That is the area. Now what it's telling me, look from this picture, between 0 and positive 1.2. But we know we get exactly the same area if we go to negative 1.2. So 0.385 is my answer. Okay, 0.385 was in the A column. All right, and they want it in percent form, so that is 38.5% of the values lie between the mean, we don't even know what that is, we don't care in this problem, to 1.2 standard deviations below the mean. So 38.5% is our answer. Now pause it for a minute and read this problem. Honestly, I'm not sure that I needed to give it to you because I think it works just like the last one. But pause it, see if you can tell yourself how to do it, and then we will do it together. All right, you ready? So find the percent of area under a normal curve between the mean and negative 1.14 standard deviations from the mean. So know that positive indicates above the mean while negative indicates below the mean. So if I draw a picture of what's happening, this is what's going on, and we have negative 1.14. Right? Now it says the area between the mean and negative 1.14 standard deviations of the mean. So what we need to do is when we have our table, we need to look for 1.14 on our table. Actually, I didn't mean to put that there. I meant to put Z there, right? So that's my Z-score, and this is A. So 1.14 is what we're going to look up, and then what we're trying to find is this A value right here, and that's going to give us that percent value that we're looking for. So if I go to a table, I am trying to find 1.14 in my Z column. Now I know it's hard to tell because I left the headers off, but remember, if the first column is Z, the second one's A, third Z, A, Z, A, Z. So this is a Z column here, and this is an A column, and remember I'm looking for 1.14, and my answer is 0.373. So that A value I'm looking for is 0.373. In percent form, that's 37.3%. Okay, find the percent of area under a normal curve between the mean and, no way, we just did that one, didn't we? At 1.4 standard, no, we just did that. Like I've got stuff doubled up. Absolutely not. How about this? So find the percent of the total area under the standard normal curve between the following Z-scores, negative 1.3 and 0.75. This is what we need to be doing. Okay? I think I had some stuff doubled that should not have been doubled. Apologize for that. Okay? So Z-score of negative 1.3. Okay? And then another Z-score of 0.75. Now, am I trying to be super accurate about where I put these? Not really. Negative needs to be on the left. Positive needs to be on the right. This one on the right is not as far over as this one on the left, but that's the part that doesn't matter as much. But I'm trying to find that area under the curve between these two. Now, let's think about how I'm going to do that versus what the table tells us, right? If I look up a Z-score of 0.75, keep putting that in the wrong place. I want to put Z right there. There we go. Z, and this is A, right? If Z is 0.75 and I look up A, what information is that telling me? Well, it's telling me this part. It's always between the Z-score, or that number of standard deviations, back to the mean. So when I look that up, it's going to give me that hash mark part. And then what happens if I look up 1.3? I was going to say if I look up negative 1.3, but I can't look up negative 1.3. So I have to look up positive 1.3, but it's going to give me the same value as negative 1.3 to the mean. And my A value, when I look that up, it's going to give me this part. Okay? Now I'm trying to find the whole shaded aqua part. So what am I going to do? I'm going to add those together. So let's look up those two values. Okay? Alright, and I think that's why I accidentally had that problem. Maybe they're both on this table. So I'm looking at 0.75 and 1.3. Let's see if we can find them here. Forgive me if they're not. Okay, remember, now let's label. So this is Z, A, Z, A, all the way across, because I did not give you the headers, because when I screenshotted the table, I left off the headers. That's what we're looking at. So remember, we're looking at, let's go back, 0.75 and 1.3. Okay, I do see, hold on, 1.3. I do see 1.3. I'm going to highlight it for you. It's right here. There's 1.3. Is 0.75 on there? Yes, it is. I thought they both fit on here. I did pay attention to this before I started doing the video, I promise. Okay, so 0.75 is 0.273. Let's fill that in. Okay, so 0.273. Okay, and then 1.3 is 0.403. Trying to get my pen working. Sometimes it freaks out on me. So 0.403. Why are we adding? Because one's on the left side, one's on the right side, and I'm trying to find that total area. And by definition of what the table gives me, it always gives me the values between the mean and that z-score, whether you go to the right or you go to the left. So when I add those together, 0.273 plus 0.403 is going to give me 0.676, if I added that right, which is 67.6%. All right, next question. We're flying through it. A normal distribution has a mean of 73.6. Okay, so they give us our x bar. Remember, that's the mean. X, again, let's get that pen working. X bar is equal to 73.6. and a standard deviation S of 4.05. It says find the data value corresponding to the following value of Z. Okay, so we're trying to find the data value that goes with this particular Z-score. Now remember, we have a formula. Okay, so remember it is, matter of fact, I have it on this page for you. I don't have to rewrite my stuff, but I do have it on this page for you. So remember, we have X bar is 73.6, and standard deviation is 4.05, and we have a z-score. Z is equal to 1.35. Your data value is that guy right there. It's X. It's what we're missing. So just fill in. You got 1.35 is equal to X minus X bar, which is 73.6, divided by S, which is 4.05. Now you got to do a little bit of algebra. I know you're taking this class because you don't want to do a little bit of algebra, but just a little, right? I'm trying to solve for this X right here. To do that, I need to isolate it. So I need to multiply both sides by 4.05, don't I? Okay, multiply both sides by 4.05 first. Those will cancel. Now I'm going to multiply 4.05 times 1.35 on the left. I'm pulling out my calculator. I'm certainly not doing this in my head. You don't want me to. That equals 5.4675. That's equal to X minus 73.6. Now remember, my goal is to try to get this X by itself. So what am I going to do now? I'm going to add 73.6 to both sides of my equation. So now X is by itself. And I get an answer of 79.0675. Now that's my X value, but look, it says round to the nearest tenth. Well, the tenth place is this guy right here, so 79.1 is what I would type in. A normal distribution has a mean of 70.8. Here I go writing. Okay, so my mean, my X bar, is equal to 70.8. And the standard deviation is 2.24, so S is 2.24. Find the data value. There we go again. That's my X, corresponding to Z is equal to negative 3.67. Does it matter if it's negative? It doesn't. You got to use the negative, though. It's not like you're going to look it up on the chart. So remember, our formula is Z equals X minus X bar over S. Okay? So you have negative 3.67 equals X minus 70.8 divided by 2.24. Remember the steps. Multiply both sides by 2.24 because I am attempting to isolate that X value. So that's going to give me 2.24 times negative 3.67, and I get negative, let's keep this blue, negative 8.2 220A. Hey, don't do any rounding in the middle of this, okay? Keep it all out there until the end. Then I'm going to add 70.8 to both sides of this equation. Notice I don't have my decimals lined up because I'm doing this in a calculator. And I get 62.5792. It also says round to the nearest tenth, so that would be 62.6 is what I would type in. Now for the funnest problems of all. Here we go. A teacher gives a test to a large group of students. The results are closely approximated by a normal curve. So once again, we have a normal curve. Do you have to draw one? No, but it sure helps with the understanding of what's going on. So the results are closely approximated by a normal curve. The mean is 72. So again, my x bar is equal to 72. That's right there in the middle. So the average test was 72. It says with a standard deviation of 5. I'm going to write that under there so I can find it. The teacher wishes to give A's to the top 8%. Okay, so this part up here, top 8%, remember that's a tail. Okay, those are A's. I'm going to put A right here, and that is 8%. Okay, teacher wishes to give, an F's to the bottom 8%. Okay. All right, so down here on the tail are our F's. I'm going to make them aqua too. To the bottom 8%. All right, and let's label 8%. Let's keep going. So the teacher wishes, we did that. A grade of B is given to the next 15%. Notice next 15%. So these folks make B's. I'm going to shade that in a different color, like softer green. And that is 15%. That green area is 15%. I'm going to write it above there. That part's 15%. And she does the same thing with D's. Okay. So I'm going to make that a nice green also. And that is 15%. And those guys are D's. And then she says everybody else gets C's. They're right. All other students get C's. Yes. Find the bottom cutoff rounded to the nearest whole number for a B. All right. She wants to know what this X value is right here. The bottom cutoff for a B. Okay. Not the bottom cutoff for an A, which would be right here. Or the bottom cutoff for a D, which would be right here, or the bottom cutoff for a C would be right here. We want to know the bottom cutoff for a B. How in the world are we going to do this? Okay, first of all, we're dealing with tails, right? I don't mean like when you toss a coin, it lands on tail. I mean like this shaded part. When you shade the ends, you're shading like the tail of the curve, is the way I'm thinking about that. Okay, now remember, when you look up something on a table, it tells you from the mean to that standard deviation value. Okay, first of all, we haven't been given any standard deviation values. We've been given percentages. Okay, percentages are like probabilities. It's like the area under a curve. These are like A values on the table. Those are like A's, not the letter A, but like A values on the table. All right, so how are we going to handle this? So first of all, the top, that whole tail right there, do you agree that's 23%? Because you got the 15% here and the 8% there. So what we're dealing with, if I draw you another picture, because I know that's exactly what you wanted, right? If I shade all of that, that total right there is 23%. But those values don't show up on a table, right? What shows up on the table is that right there. How am I going to calculate that? Oh, I know you know. That is 50% minus the 23%. And what is 50% minus 23%? Yes, indeed. That is 27%. Remember, that's not a z-score. That's the A value on the table. So here's what we set out to do. I go to my table, and I have a z-score and an a-score. My A, well, not an a-score, but an A value. My A is 0.27. I have to find my z value. Now, before I go find that Z value, I want to let you know that doesn't answer the question. We're still trying to find the cutoff for a B. But I need to know the associated Z value so I can do what we did in the last problem to find that data point, that X value. So let's go find the Z value associated with 0.27. So remember in your homework, to get to these tables, you have to open up one of these two links that's listed here. This is probably, it says it's page 1. This happens to be page 1. And I put the columns back there for you, Z's and A's. Now, we have an A value, which was 27% or 0.27. So I'm checking out all my A columns, and I'm looking for 0.27, and I see it right there. Now don't go right, because remember the associated Z value is to the left. So right there, I'm at Z of 0.74. Okay, so I go back to my work, and now I know that Z is 0.74. Now how am I going to find my X value? Well, you know the formula, right? It's X minus X bar over S. That equals to Z. So I'm going to plug all that stuff in. Y'all, I'm going to erase a little bit here, get rid of my curve, get rid of some of this work. If you're missing it, just rewind the video, go back and look, write that stuff down, and let's do this calculation. So remember, Z is 0.74 equals X, that's what I'm looking for, minus my X bar right there at 72 over my standard deviation of 5. And I need to solve for X. So what am I going to do? I'm going to multiply both sides by 5. That's my first step. And I have 0.74 times 5. And that gives me 3.7 is equal to X minus 72. Then I'm going to add 72 to both sides. And I get that X is equal to 3.7 plus 72. How about 75.7? That is my low value for a B. Something I should point out real quick, I didn't read directions. Notice it says round to the nearest whole number. So the cutoff is not 75.7, it is 76. So 75.7 rounded to the nearest whole number is 76. Be real careful, read directions. I tend not to sometimes, and it gets me in trouble. So there we go. I've got one more problem, very similar. Hang tight, and we will knock this section out. And for the last problem, I want to do this, but I want to find the bottom cutoff for a D. Somehow I lost my slide, and I really did intend to do this, and it does read that way, but I lost the original slide that says a bottom cutoff for a D. So let's do this. Now, remember, if I go back to my picture, let's don't reinvent the wheel. Let's go back and look at the picture where everything is defined. Okay, so I'm looking over here. Woo! I really wish my pen would work each time I change slides, but it doesn't, and that's why I do stuff like that. Okay, so all I'm trying to do is look at this picture right here. So a bottom cutoff for a D is this value right here. Do you agree? Anybody that makes this score to here is going to get a D. Okay, so my percentage that I know that's associated with that is just the 8%. I don't have to add 8 plus 15 because that would give me a C value. If I had 8 plus 15, I would be in the C score range. So what I'm dealing with here is just the 8%. But remember, my A is not 8% because that's the tail. So I have to do 50% minus the 8% to get that. You with me? Okay. So let's do 50%. Yeah, get your pen working, Wilson. Okay, so 50% minus the 8%, that gives me 42%. So if I draw the picture, the curve again, the 42% is this. Okay, and that is the beginning of a D. Less than that, over here on the tail, you would make an F. Okay, so at 42%, if I could figure out what value is associated with 42%, I would be great. So then I need to go to my table, and I'm looking for what Z is associated with an A of 0.42. I'm just trying to remember, find that z value. Okay, so let's go to the table. Hey, look at that. And I have it highlighted. Why do you think that is? Well, I'd already looked it up. But I don't see a 42, right? I see a 0.419 and a 0.421. 0.421 is too much. 0.419 is not enough. But if I round, I'm not trying to move that, I'm trying to write on it. If I round this value right here, it really is 0.42. So that's the value I need. It's associated with a z-score of 1.4. Okay, so I go back to my work and I know that z is 1.4. Now, what am I going to do with that? Well, remember, I have to find the data point associated with that. So I use my formula. Z is equal to x minus x bar over s. So I have 1.4 is equal to, and really it's negative 1.4 because it's on the left side, right? But that's of not issue because it's symmetric. So I have x, that's what I'm looking for, minus x bar. Now what was that? Let's go back to our sheet. Actually, it was on that page. The mean is 72. Let's circle it. So the mean is 72 and the standard deviation is 5. So it's x minus 72 over 5. Okay. Now, does that negative matter in this case? Well, it doesn't when you're looking up the table, but doesn't it when you're doing the calculation? Yes. Yes, it does, because we are below the mean. So if I said that it doesn't matter, I lied to you. It matters when you're doing this calculation. It does not matter when you're looking it up on the table. I apologize if I confused you. I think I confused myself there for a second. I need to multiply both sides by 5, remember, because I'm trying to get that to cancel. So I have negative 1.4 times 5, and then I'm going to add 72, right? So negative 1.4 times 5 is negative 7, plus 72 gives me 65. Okay, I hope that homework round helps you out and gets you through this last set of homework. Have a wonderful day and reach out if you have questions.